Hello everyone. Today we are going to solve GFG problem of the day. Longest subarray with majority greater than k. So let's see what the problem says. So in the problem we have been given an array and one k. So in this array among all of its subarrays we have to find the the longest subarray in which the elements greater than k are more than elements lesser than k. So if you see its sub-arrays, this part 2, 3, 4, 2, 3, 4. So if you see 2 is lesser than or equal to k, so 1 and 3 and 4 are greater than k, so 2. So this is a valid answer because here the number greater than k are 2. So among all those its sub-arrays, we have to return the longest. So this is the longest. There is also one more answer which is valid in the range of possible answer 341. But the longest is the longest length is 3. So we have to return that. There is one more answer 3 and 4, but it is not the longest. Here greater than kr2 lesser than kr0. It is also valid answer, but it is not great. It is not the greatest, like not the longest. So this can be a possible answer, this can be a possible answer, and we have to return its length. So its length is 3. So for this case the valid answer is 3. So let's move ahead to its solution. So the first solution that comes to mind, brute force. And brute force is find all the sub arrays, and among all those sub arrays check if if the number of elements the greater than k, whatever that is, keep checking, and among them whatever is the maximum, return that. So its time complexity will be generating all the subarrays first thing, and among those subarrays we have to check all of its elements. So it would be n cube of time complexity. So let's try to reduce the complexity. So does this problem sounds like majority element? To me, yes. It is mostly like majority element, but in majority element, what we have to do is any element that is occurring more than n by 2 times, just only that much. Here we have to find it in sub arrays. So let's see what we did in majority element. So I am not going to explain that, but what we did, we will get some context from that one. So in majority element, what we did is this one was cancelling this two, this three was cancelling this four, and if at the end something is there that was a possibility for the majority element. So for majority element, we use Moore's voting algorithm, something like that can be used. So here, if I say the element is smaller than k, if that can cancel element greater than k, in if those cancel each other, can I say that I can find my answer? So let's say this 1, in this case, this 2 is cancelling this 3, but it was not able to cancel this 4. So if I am considering this subarray, 2 cancelled 3, but it was not able to cancel 4. That's why this was my possible answer. So how can we do that? So whenever cancelling is considered, we can say -1 will cancel +1. So element lesser than k, if it is less than k, we will store -1, and greater than k, we will store +1. So for 1, we will store -1. 2, let's say less than equal to k, we will store -1. 3 greater than k +1, 4 greater than k +1, and 1 lesser than k is -1. So what it is storing is, like, it is storing in if we can cancel it, like it is storing for lesser than k minus 1 greater than k plus 1. And now in if we consider this part, minus 1 cancelled this plus 1, but this plus 1 remains. So there is a possible answer in which there is one element greater. So this logic we are going to use in our problem. So now the problem reduce after creating this array minus 1 and plus 1, our problem reduces to sub array sum greater than 0. And we already know sub array sum equals to k. We already know. So similar kind of approach we are going to use just with slight modifications. Here what I want to do is sub array sum greater than 0. So greater than 0, if I find sub array sum equals to 1, will it work? Let's see. So for this I'm sure it will work. But what if there would have been 1 plus 1? So in that case, we would have also included this one. This one also would have worked. Okay. Let's say there was already 1 plus 1. In that case, our answer would have failed, because here what we are doing is we will be keep looking back, and in that we will be finding if there is anywhere we are having someone, but not. This is not the case, right? Because here my plus positive sum is 4, negative sum is minus 2. So if you 4 minus 2, we will be looking 2 plus 2, and there would, if there is, let's suppose no 2, what will be mine? So in that case, if you see, this whole part would have been my answer. So there is one slight modification with sub array sum equals 1 plus among them, if anywhere my complete sub array becomes positive, then that would be my answer. So from starting, if any point my sub array becomes positive, that is a possible candidate for my answer. So the problem reduces to sub array sum equals to 1, but with the condition check, if my prefix sum becomes positive, that would be my answer. So considering those two constraints, we can write the code. So let's do one iteration, like how we are going to do that. So let's say at the starting, I am putting minus 1. Why minus 1? Earlier we were putting 1 in sub array sum equals to k. There we want count. Here we want indexes. So that's why 0 is not even present in my array. So I am storing it as minus 1. I came at minus 1. This is my minus 1. Like my sum is minus 1, and I will check is minus 1 is there. Why minus 1? Because we are checking sub array sum equals k is equals, like sub array sum equals 1. So that's why I'm doing sum minus 1 every time. So here minus 1, and it is occurred at index 0. Now minus 1 minus 2. So I will check, is there any minus 2 minus 1, that is minus 3 in or not in my map. So if you check, nothing, if this is my map, there is no minus 1. So just store its index. We came plus 1. Now this sum minus 2 plus 1 is minus 1. And we will check, is minus 1 that is minus 2 or there or there on in my map or not. So minus 2 is there, its index is 1. So nothing to do, just keep one answer and just update answer with whatever the current index is. Current index is 2. 2 minus whatever this index. So 2 and minus 2 was at index 1. 2 minus 1. So it is 1. Just this. So update our answer. And why update? Because let's say at the starting my answer is 0. If I find something greater than answer, update my answer. That's it. And minus 1's index, if it is not there in my map, I will put if it is there. See, minus 1 is there at 0. I will not even touch it. Now minus 1 plus 1, 0. Okay. So I want to do is minus 0 minus 1 is there or in my map or not. So 0 minus 1 minus 1. So minus 1 is there in my map and its index is 0. And currently I'm at index 3. So 3 minus 0, that is a 3 length. So I will check if my 3 is greater than my answer. So yes, so I will update my answer. And 0 was already there, so no need to touch it. So if you see here, what we want 3. What 3 it is saying? These 3. Right? So these 3 we have got it in our answer. If you see, we got minus 1 at 0. From next to it till this point, there is one possible answer. Let's move ahead. Here we will find some more, like something we are missing. So now my sum becomes plus 1 and 1 minus 0. I will check, that is 1 minus 1, sorry, 1 minus 1. Or sorry, 1 minus 1, that is 0. So is there any 0? Yes, 0 is there. So if you see what at this point, right? Let's say this was 5. So 0 means till from starting till this point, there is one possible answer. If you see 3, 4, 5 greater than k, so this we will store it sum as 1 and it is at index. It was not there, so its index. Now again plus 1 came 1 plus 1, 2 and 2 minus 4, like sorry, 2 minus 1 equals to 1. And if we found in our map, is there any 1? It will say yes at index 4 and there our answer becomes wrong. So let's say there is another element that is corresponding to this. So I would say, is there any 1? Yes, 1 and at index 4 and now I am at index 5. So I will try to update my answer. Let's say this is 4. Now I will try to update my answer with 1. My answer is already 1. But if you see, we missed this whole part. If you consider this whole part, 3, 4, 5, 6, 4 element greater than k and 2 element lesser than k. But in our answer, what would be the size? 1, 2, 3, 4, 5, 6. The size would be 6. But it is storing in our answer 4. The last one, it didn't even update it. So we will miss. So that in that case, if our sum is greater, if our sum is greater than 0, that is denoting from starting till this point, there are elements of k, elements which are greater than k. That's why that is only possible. That's why it is still here that our prefix sum is positive. So that thing we need to take care. Other things, this subarray sum equals 1 will take care. So let's move ahead to the code and let's code it up. So first I have created a hash map and Let me paste the code and I will explain it because video is getting too long. So let me copy this code I have already written, and this I have written whatever I have explained, nothing extra, but I will be explaining it as well. So currently we have created one prefix sum that will store map as we discussed, and count. Count is nothing, that is our answer that will store the, that will be keep updating whenever we find something larger. And in add map starting we have put -1 as we discussed. Now we are running a loop in our array, and if it is greater than k we are doing +1, and if it is lesser than k we are doing minus minus. And if you see here, we were using this array, right? But to maintain this prefix sum, minus, if we take -1 +1 and keep summing, we will even not even need this sub array. So we can even neglect that. And what we are doing here is, if it is lesser, we are taking -1 and keep summing it to prefix sum. We don't have to look back in the array. So for under explanation purpose, I have created, but in real one, we don't want to increase the space complexity. So if it is lesser, we are storing and we were summing it to prefix sum. That's it. We don't need that. So we will keep summing it to our prefix sum, and if at any point our prefix sum was greater than 0, as we discussed here, if at some point our prefix sum became, let me control Z it. So if this point my prefix sum becomes greater than 0, that means from starting till this point this is positive. So that was a possible answer. We don't have to check in that one. So in that case, we have updated our count, because from starting till this point, if this is I'm getting that, that is that is possibility that this would be my maximum. Otherwise, we will check if my prefix sum like is it is lesser, then I will check if in my map I am getting some like whatever I am positioned at -1. So if it is there, I will check with current index minus at that point what was the index. So this is doing what, and at the end, if there is no element in my map, like if that sum is not there in my map, I am adding. Just this much we have to do. Only modification was this. If my prefix sum is greater than 0, this part, and rest of the things I think same, just here only index. I hope you got the idea. Let me submit it. It should compile because I have already ran the code. So I hope you got the idea of the problem. If it has helped you a bit, you can like the video. Thank you.